Welcome to this chapter on theory and operation of the jack code jf017e CVTT iron transmission. This will include computer strategy, component pinouts, solenoid strategy, clutch apply charts, related input and output devices, and hydraulic diagrams. My name is Jared Warren, and I will be your host for this chapter. It is a great day to fix transmission, so let's get started. Here's just a cutaway side view of the transmission. Up front, you gotta have your torque converter, which is attached to your input shaft, of course, and in your reverse clutch, it's right here. In the case, it's your reverse clutch. Here's your forward clutch, and your planetary is right here. This is your primary pulley. And here's your secondary pulley. Of course, it's attached between the two with a chain, or actually a belt. Gear up here towards the front of this secondary pulley that powers the transfer gear. The transfer gear turns the differential, and the power goes out the spider gears to the axles. Here's a side view of the all-wheel drive. The difference here is basically there's a longer section here for splines for the all-wheel drive unit to bolt to. Main components, we get the torque converter. It's the same basically as any of the other converter, conventional. Three element, one stage, two phase type converter. So it has a lockup clutch. Lockup comes in about 10 miles an hour or so. This is an off-axis pump, meaning the pump's not bolted to the stator and is not driven right directly off the converter hub. This one has a chain and a hub. So off the converter hub there's a gear sprocket, and that powers the pump, which is down in the bottom of the pan. Or the bottom towards the case, not necessarily in the pan. The clutch and planet sets, we have one forward clutch, and we have one reverse clutch, and one simple planet. That gives us reverse. We got the belt and the chain, or the belt and the pulley. Basically two sets of pulleys, and the pulleys open and close, which changes the width of the groove of the pulleys. And that way with the belt in between them, that forces the belt to go up and down and changing the ratio. It's smooth. You don't feel the shifts or anything like that, so it should be a nice smooth transaction. RPM's a little bit high, and then you start coming down. It's kind of it's a weird driving feel, that's for sure. People are starting to like it more and more. It's a very popular unit, though, that's for sure. This is a diagram that shows each of the components' controls. So you can start over here on the left and say the TCM. It controls, let's say, line pressure solenoid. The line pressure solenoid itself controls the pressure regulator valve. Pressure regulator valve controls oil to from the oil pump, controls the oil there, and it gets controls the lubrication oil, and also everywhere else to all the manual valves, other solenoids, clutches, of course. So if we pick the pressure valve solenoid, TCM controls it. Oil is coming from the pilot valve A. So that pilot valve A is a solenoid regulator valve that sends oil to this primary solenoid. Primary solenoid adjusts the pressure on that, and it goes to the primary reducing valve. Primary reducing valve sends oil to the primary pulley, and that's kind of how this chart works. You start on the left, the TCM, how it's controlled, what it controls to going towards the right. For some inputs and outputs on the strands, what controls the stranding. So we'll start here. This is basically the center of the transmission. So oil pressure control, like line pressure, that kind of stuff we were talking about. So here's oil pressure control, of course. We'll follow this backwards. Let's see, we can go here to the torque converter, of course, controlled by engine or oil pressure. Forward and reverse engagements, all oil pressure. Belt and pulleys, all oil pressure. So everything kind of based off hydraulics, of course, in the unit. But you can go from the transmission out to what controls it. Now let's just get some of the different inputs and outputs. So we have the input, we have an engine torque signal, engine speed signal, accelerator pedal, close throttle switch, brake switch, primary pressure switch, secondary pressure switch, fluid temps, and then of course our speed sensors on the transmission and engine, the range switch, and the overdrive control switch. Some of the outputs, you're looking at line pressure solenoid, primary pressure solenoid, torque converter clutch solenoid, secondary pressure solenoid, select valve solenoid, range switch, overdrive control switch. Now there's more things that can be considered an output, but this is the majority here. Transmission strategy, pressure management, and powertrain management. So basically the TCM becomes the protection control module. You know, its job is to run the transmission and make sure it shifts smoothly and changes ratio smoothly and stays, it controls the transmission. So it gets all this information from not only the transmission, the engine, the ABS modules, and it wants to protect the transmission, make sure nothing happens to it. So when like the wheel spin, we got different protection modes, different driving scenarios, and how things are affected by it. So control for wheel spin. So when it checks like one of the wheels is skidding or one of the wheels is spinning, first thing it wants to do is to cut the engine power, and it wants to. Usually it'll change the ratio or lock the ratio to where it was. It increases line pressure so the transmission doesn't slip. And a lot of times you'll feel where you get the complaint of no engine throttle on this unit. On a lot of the CVTs too. So if it detects a wheel speed sensor that's erratic or missing, it's gonna think that you're skidding along or in a dangerous situation, so it'll cut engine power and throttle body. So you hit the gas and there'll be nothing there. Just check all your systems when this happens. Driving in reverse is, of course, it's controlled by the vehicle speed. So the engine output is controlled by the vehicle speed while in reverse. Power performance may be lowered also. So it's saying you don't need much power in reverse. We'll give you this much power to go ahead and operate, but you're not going to go racing in reverse, of course. Reverse prohibited. One thing that can happen is, let's say you're going down the highway and the kid bumps the shifter and it goes into reverse. Well, they now have protection mode, and they have it for years on some units, but it's a reverse lockout. So you can put it in reverse accidentally, and while you're moving forward, it's not going to engage. Not until the RPMs or the mile per hour get down below a certain point, then it will go ahead and control the reverse clutch. And that's how it kind of protects the unit from self-destructing accidents like that happen. Transmission fluid and high temperature. When the CVT fluid temps is high, the gear shift permission, maximum revolution, and maximum torque are reduced. So basically what they're saying is if transmission is overheating, it's going to control the lockup clutch. It's going to put it in a higher ratio so it's not revved up or creating heat until the temperature is back down to normal. Alright, here's the pinouts we have. We have a transmission case connector view on the top left. We have the range switch. And then we have the TCM F15 pin. So we can do a lot of checks and evaluations right here at the range switch, TCM, and the transmission case. We need to also use these pin numbers in chart. You can do the range switch here. You can see this is the low switch right here. You can see the two terminals that you're going to be using on that. And here's your drive, neutral, reverse, park. All these two terminals you can go back and forth to and see if the wire is good, that kind of thing. So if you want to check the wire like the primary pressure sensor, it'd be number 13 at the trans over here, so it'd be this terminal over here on the right. So you'd want to check that wire here, or use a chart and you can check the wire at pin number 17, which is right here. So this basically are the same wire. The wire runs from 17 to 13 for the primary pressure sensor. Another thing we can do with the case connector is check some solenoids. So if you want to do your transmission fluid temperature sensor, here's the specs here down the bottom, about 6.5K, that are 1000 ohms at 68 degrees. If we want to check it, we could go number 12 and number 18. Between those two voltages at the transmission, you should have about 6500 ohms at about 68 degrees. Here's your solenoid ohms here. So if you want to go ahead and check your ohms, determine which solenoid you're looking at, or where the solenoid is that you need to inspect. On the valve body itself, it's kind of easy to get these solenoids kind of mixed up, so I'd always mark the solenoid before you take them apart. Take a couple pictures. Note the secondary pressure switch is gray, primary pressure switch is black. There may be other combinations. Make sure you pay attention to what switch goes where, and do yourself a favor, take a little picture of it. Then go ahead and pull the switches off and clean the valve body and all that great stuff. Here's the range switch, easy to check. The double zeros here are for neutral switch. So park and neutral. It's number 7. Number see 10 and so pin 4 is your battery power. So you're going to go 4 here. Is a common wire. 5. So to check park, you go 4 and 5, and you should have continuity in between those two. Check reverse, you're going to go 4 and 8. Neutral would be 4 and 9. And then in drive, you have 4 and 2. And 6 and 4 is going to give you low. speed sensors. Let's start here on the left. This is your input speed sensor. Goes above the transmission warmer, and it reads off the reluctor here on the input shaft drum. Primary speed sensor, it's in the back. It's reading off the primary pulley, this little wheel here. This wheel gets bent very easy, so make sure you take care of it. And if you do bend it, you need to flatten it out, make sure they are nice and straight. We've gotten quite a few calls on bent reluctors just because of that dinged up in the parts washer. And then you have your output and your secondary speed. That's reading directly off the differential itself. Alright, so speed sensors. All the speed sensors are battery voltage fed. So on pin 3 is battery power. And then pin 2 is your signal, so it's the center wire. And then pin 1 is ground. Easy to check. Meter on ground, back probe 1. Make sure it has good ground. Back probe 3, make sure it has power. And then you want to put number 2 on a scope and check the scope reading. And you should have a square wave signal. The faster you go, the closer the square waves are together. As you slow down, the waves are going to get farther and farther apart. That's what tells the computer what speed you're at and how fast you're going, all that great stuff. Alright, pressure switches. Pressure switches are powered with 5 volts. The sensor voltage is what it's measuring, and then the wires for ground. So the primary pressure sensor detects the pressure to the primary pulley. When pressure is applied to the pressure switch, in there's a ceramic device in there that gets deformed. So kind of think of like a little flat piece of paper, and when you put pressure on, blow pressure on the paper, what does it do? It kind of deforms and it blows up in the middle, tries to expand, that kind of thing when you're blowing on it when it's flat. So it's trying to move it. Well, that's what the pressure transmission is doing too. It's getting pressure in behind it. It's forcing that diaphragm or that piece of ceramic in there to stay open where the switch is open. Put pressure in there, and it's going to put pressure on the ceramic, close it, and operate the switch. So this is just basically pressure switch. Secondary pressure is doing the exact same thing. It's measuring just a secondary pressure circuit. So we've seen, back to the colors. We've seen quite a few different colors on these pressure switches and different styles of them. So make sure you get the correct one. Here's some more pinout charts. Now we're talking about the transmission temperature. So here you can go cases pin number 12 and 18. And then TCM pin would be 11 and 12. So we're giving you 2 different options again to check the temp sensor. See, 20 degrees Celsius, 68 degrees, it should be 6,500 ohms. Now, if you're driving the car around for a little bit and you're at 122, you should be reading 2.2 thousand ohms. And last but not least is 176, probably a normal operating temperature. We should be about 870 ohms. Here's the clutch supply chart. It's very simple. Nothing really is effect in park. or neutral. So in reverse, you have your reverse brake, and you have your planetaries doing the powertrain. The planets are doing the power flow, and to drive the car, there's the power. You have the primary pulley and secondary pulley. So this is basically a flow chart and a clutch application chart. So in drive, what do we have? We have the forward clutches on. The forward clutch is connected to the primary pulley. The primary pulley is pushing the secondary pulley through the chain and out to the final drive. Alright, note the passages at the front of the transmission are for pressure taps. The main air test would be forward and reverse clutches. When air testing the secondary and primary pulley, it is normal for the belt not to move at times. The belt needs rotation of the pulley and pressure at the same time for the belt to move up and down the sheave like it should. See, so forward clutch is over here, and then you have your forward clutch pressure tap. So what we're trying to say here is these up here are, you go to the plugs. As you see here is a forward clutch pressure tap. You blow in here, it ain't going to do nothing at all. It's just a solid hole that has a pressure tap in there, so you can measure forward clutch pressure. So that is connected through the valve body over here to the forward clutch and out. Over here is the pump. You have pump section in, pump section out, secondary pulley pressure here. Now we're dealing with the solenoid firing chart. Okay. So in all gears we have your line pressure solenoid active. It can build pressure as soon as it's needed, or it can keep a low pressure, keep fuel economy and stuff down. So in park we have nothing except just line pressure solenoid. Reverse, we have what they call a select solenoid. Basically it's a switch valve solenoid. It changes positions to route the oil differently from the manual valve to the reverse clutches, and the reverse clutches give you power out to the transmission. In neutral, we have nothing applied except the line pressure control solenoid. And then in drive, we have the select solenoid again. On engagement, it's sending power to the primary solenoid. Secondary solenoid is also in effect, so primary and secondary solenoids are changing ratios, making it able to drive in forward, and then lockup's about 10 miles per hour. You notice that in reverse, the primary and secondary pulleys do not have oil pressure to them. They don't want the ratio change to change in reverse. They don't want people driving in reverse. Alright, so operation of linear solenoids. So we have the selection solenoid, the line pressure solenoid, secondary and primary solenoid are all normally high solenoids. When low amps is applied to the solenoid, or when you activate the solenoid, it's going to go to full pressure on the solenoids. Pilot valve A, which we'll show again in the valve body. It was on the last few slides. But Pilot A is a solenoid regulator valve. Its job is to send oil to the solenoids to keep it in a workable area. You can sometimes understall this thing that has 600 psi, and if these solenoids weren't regulated down, we would have 600 psi. So let's just talk about the passages here real quick. We already said pilot A is our supply oil, so oil's going in here, and then the balance oil and the control oil is coming out directly right here. So pilot oil through the solenoid out to control area, and then when they want to change pressures, they change the amperage to the solenoid, and you'll see the pressure go up or down. And this balance controlled side over here is what keeps the pressure consistent. Now back over here to the solenoid layout. These are the little solenoid retaining pins. Make sure you pull it out and don't lose them. Here's the wiring harness. Now for the TCC solenoid, it uses pilot valve B, which is another regulating valve. You have pilot oil or feed oil going in between the two O-rings, and then you have the controlled amount of oil going into transmission, TCC valve in this case, and it also has a vent to vent the solenoid. All the resistance should be 6.1 to 7.7 ohms. And here we have basically the same thing again. This is the upper valve body. We're going to start installing the valve body together. Put in all your linear solenoids. They all have little holes right here next to the solenoid. Make sure those don't fall out when you're putting everything together. Couple things to notice here. Look at the filter, and the open end goes into the valve body first. So here's the open end here on the bottom. The top end's closed, and we had to install it right here. Very hard to tell exactly what's going on here on these filters in the direction sometimes nowadays. But this one seals in the casting, and oil goes around it. Check balls. There's one check ball and a spring over here, and there's 4 small check balls up here in this corner of the valve body. It should be right around 250 thousandths, and those 4 balls are for reverse engagement and forward engagement. Now, to confuse you, filter on this side of the valve body is solid end in first, and the open end towards the plate. So last valve body we said the opposite of that, so that's why you're really going to watch out on this unit, which way the oil's coming in. So for as the valves, we have your manual valve, of course. Here's your TCC control valve. This plunger here likes to stick fairly often. Here's the TCC regulator valve. Again, this little small valve will stick in this boost valve. Excuse me. And that's on the TCC regulator. Then we have your pressure regulator here. Make sure there's no wear in the bore. Make sure the valve's nice and free. Clean it all out. Make sure the end plug's fairly tight. Secondary reducing valve. Check that valve. Clean the spring. Check the end plug. And it goes right in here. Okay, this is the transmission temperature sensor location. It's right here in the pan. As you see, here's the filter. One thing you gotta really make sure when you're doing this is this wire doesn't get pinched, and that it is off to the one side. And then some other sensors. Here's your input speed sensor right here we talked about. Here's a better picture of it though. the range switch on top, your secondary speed sensor, and your primary speed sensor. It's good to have it to get into pulling those sensors off transmission before you start working on it, rolling around on the bench. As you see this one here, the primary speed sensor, it's broken up, and that's exactly why. It's been rolled around and it's been beat on just because it's so awkward to sit around. Doesn't really set too flat on the bench. You can roll over real quick. You gotta pull it, put everything on its back, so if you put the transmission on its back and you don't pull these solenoids, it's gonna break them. This is going to conclude our chapter on theory and operation of the jf017e transmissions. We want to thank you for participating in our virtual training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.